Good morning, everyone. I'm Dhriti from Venkateshwara College of Engineering, Bengaluru. I will give a small presentation on solar powered space cooling for buildings. Let's move to the introduction. Introduction. Solar space cooling is a sustainable and cost effective way to cool buildings using the power of the sun. This technology uses solar thermal collectors to absorb heat from the building and transfer it to a cooling system, which can then be used to cool the air or water in the building. We can see the working here. The system consists of two parts. The solar collector and the storage is one thing, and the second is the absorption air conditioner and the auxiliary heating. The essential components of the cooler are generator, condenser, evaporator, absorber, heat exchanger, and which is mentioned with G, C, E, A, and H, E. The operation of air conditioners with energy from flat plate collector and storage systems is the most common approach to the solar cooling today. In essence, cooling is accomplished as the generator of the absorption cooler is supplied with heat by a fluid pumped from the collector storage system or from the auxiliary. Heat is supplied through a solution of refrigerant in absorbent in the generator, where refrigerant is distilled out of the absorbent fluid. The refrigerant is then condensed and it goes through a pressure which will reduce the valve to the evaporator where it operates and cools air or water for the cooling space. The refrigerant vapor goes to the absorber where it comes in contact with the solution which is weak in refrigerant and which flows from the generator. The vapor is then absorbed in the solution, which is then returned to the generator. The vapor is absorbed in the solution. A heat exchanger is used for sensible heat recovery and greatly improves cooler COP from the point of view of use of a conventional energy source. There is a single index of performance for rating cooling processes, that is the COP, the ratio of the amount of cooling to the energy required. For solar operation, there are two additional factors: the temperature required in the solar collector to drive the process and the ratio of cooling produced to solar energy incident on the collector. These are the main steps which has to be followed from the previous slide to this slide, and we are going to see the further working and how it happens. As solar processes are inevitably transient in their operation, the energy ratios and temperatures will vary with time, and COP based on long-term integrated performance provides an appropriate index of performance. Pumping to more absorbent solution may be by mechanical means or by vapor lift pumping in the generator for low pressure systems like LIBR and HO2, that is lithium, barium, and water system, which require water cooling of the absorber and condenser. Systems in this type, which is shown in the figure, have been the basis of the most of the experience to date and with solar air conditioning. We can see the image in the next slide, and before that we can tell more working is that the coolers which are used in most experiments are that is the lithium and the pressure machines, water cooled absorber and condenser. The pressure in the condenser and the generator is fixed largely by temperature drops across heat transfer surfaces in the generator and the condenser. The pressure in the evaporator and the absorber is fixed by the temperature of the cooling fluid to the absorber and by the temperature drop across the heat transfer surfaces in the evaporator and the absorber. Thus, to keep the generator temperatures within the limits imposed by the characteristics of flat plate collector, the critical design factors and operational parameters include effectiveness of the heat exchangers and coolant temperature. Common practice in solar experiments has been to use water-cooled absorbers and condensers, which in turn requires a cooling tower. So we can consider this is the explanation or the working of the solar space cooling of buildings, that is vapor absorption air cooling using the lithium borium water system up to 85 to 95 degree Celsius. This is the block diagram for the working of the solar space cooling of buildings. We can see here we are going to have a pump, we are having a storage tank, heat exchanger, auxiliary heater, cooling, and just the block diagram we can see here. Let's move to the advantages. That is, it is renewable energy, cost savings, low maintenance, reduced energy consumption. Renewable energy. Solar space cooling uses renewable energy from the sun, which is abundant and free. This reduces dependence on fossil fuels and hence reduces greenhouse gas emissions and environmental pollutions. Once then we are going to cost savings. Once installed, solar space cooling systems can save a lot of money on energy bills since the energy used is free and there is no fuel to buy. Low maintenance. Solar space cooling systems are relatively low maintenance. The solar collectors can last for decades and the systems do not require regular maintenance like conventional air conditioning systems. Reduced energy consumption, that is, solar space cooling systems can help reduce energy consumption since they use less electricity than conventional air conditioning systems. Let's move to the disadvantages. Disadvantages: high initial cost, climate dependence, space requirements, complex technology, limited efficiency. High initial cost. The initial cost of installing a solar space cooling system can be very high, which makes it less accessible to who cannot afford the installation. Then comes climate dependence. Solar space cooling system depend on the availability of solar energy, which can vary depending on the weather, location, and time of day. This means that the system's effectiveness can be reduced on cloudy days or during the winter months. Space requirements. Solar space cooling systems require significant space to install, especially the solar collectors, which can take up to a lot of roof space. Complex technology. Solar space cooling systems are more complex than conventional air conditioning systems, and installing requires specialized knowledge and training. Limited efficiency. The efficiency of solar space cooling systems is limited by the technology's current state, which means that they may not be as effective as conventional air conditioning systems. These are some of the disadvantages of the these are some of the disadvantages of solar space cooling of the buildings. Thank you.